Roldan Jimeno, a third-year student of BS Electrical Engineering at Don Mariano Marcos Memorial State University, Mid-La Union Campus, under the advisory class of Engineer Joel Rodelio Dohenya. The current that we will discuss today is the energy stored in the capacitor, and our problem is the current in a 0.25 farad capacitor is I is equal to 4 sin 2t amperes. The initial voltage is 4 volts. Find the maximum and the minimum values of the stored energy and the smallest time at which each occurs. First, we will draw the figure of the problem. Our voltage source is unknown. And our capacitor is 0.25 farad. And the voltage in the capacitor is 4 volts. Voltage na capacitor is equal to 4 volts. The current that is running in our capacitor is I is equal to 4 sin 2t. The first thing that we will do is get the minimum value of the stored energy. The formula that we will use is E is equal to 1/2 times capacitor times Vc squared. C is the capacitor and the value of the capacitor is 0.25 farad. And Vc is the voltage of the capacitor, which is 4 volts. E is equal to 1/2 times the value of the capacitor, which is 0.25 farad, and the value of the voltage of the capacitor, which is 4. And the answer that we will get is E is equal to 2. The unit of energy is joules. And the time at the minimum is T is equal to 0 seconds at minimum. To get the value of the voltage source, the formula that we will use is Vc is equal to C times Vs. The value of Vc is 4 volts. And the value of the capacitor is 0.25 farad times the voltage source, which is unknown. And to get the voltage source, we will divide both sides by 0.25. We will cancel 0.25 and 0.25. Now the voltage source is equal to 4 all over 0.25. The answer that we will get is equal to 16 volts. The next step that we will do is to get the max voltage of the capacitor. And the formula that we will use is Vc max is equal to the voltage of the capacitor plus the voltage source. And the voltage of the capacitor is equal to 4 volts. And the voltage source is equal to 16 volts. If we will add the value of the capacitor and the value of the voltage source, the answer that we will get is VC max is equal to 20 volts. As we obtained the max voltage of the capacitor, which is 20 volts, we are now ready to get the maximum value of the stored energy. And the formula that we will use is E is equal to 1/2 times C VC squared. And C is equal to 0.25 farad. Now, we will substitute the value of C and VC into the formula. E is equal to 1/2 times the value of the capacitor, that is 0.25 farad, times the voltage of the capacitor, that is 20 volts. And the answer that we will get is 50 joules. To get the T at maximum, we will equate the formula dQ all over dt, that is equal to I. And we know that I is equal to 4 sine 2t. So we will write dQ all over dt is equal to 4 sine 2t. In order for us to get the value of t, we should integrate both sides. Integral of dq over dt is equal to, we know that 4 is a constant. That's why the only part of the other side that we will integrate is sine 2t. And the integral of dq over dt is equal to q. And the integral of sine 2t dt is equal to negative 1/2 cosine 2t. As we simplify, q is equal to 4 times negative 1/2 cosine 2t is equal to negative 2 cosine 2t. Let's set this as equation 1. Now that we set q is equal to negative 2 cosine 2t to equation 1, we will get the value of q. And q is equal to the charge of the capacitor. Since Q is equal to capacitor times the total voltage of the capacitor, C is equal to 0.25 farad. And the total voltage of the capacitor is equal to unknown. To get the total voltage of the capacitor, we should get the sum of the voltage of the minimum and the voltage of the maximum, where Vt is equal to V minimum plus V maximum. In order for us to get the V minimum, we should redraw the figure. the voltage source at minimum is equal to 16. And the voltage of the capacitor at minimum is equal to 4 volts. For us to get the V minimum, we should apply KVL. And V minimum is equal to, from negative to positive, positive 16 volts. And from positive to negative, negative 4 volts. Where V minimum is equal to 12 volts. Now that we obtain the value of the minimum, which is 12 volts, we will also get the voltage at the maximum. And to get the voltage at the maximum, we should also redraw the figure. Voltage source, that is 16 volts. And the voltage of the capacitor at max is equal to VC is equal to 20 volts. To get the voltage at the maximum, we should also use KVL. To get the voltage at maximum, from negative to positive, positive 16 volts. And from positive to negative, negative 20 volts. And if you will simplify, Vmax is equal to negative 4 volts. And Vmax is equal to negative 4 volts. Where 12 plus negative 4 volts is equal to Vt is equal to 8 volts. Now that we obtain the total voltage of the minimum and the maximum, we can now get the charge of the capacitor, where U is equal to the value of capacitor, which is 0.25 farad, times the value of the total voltage, where 8 volts, and charge is equal to 2 coulombs. Now that we get the charge of the capacitor, we can now easily get the time at maximum by substituting 2 into the equation 1. Now, to get the value of t, we should divide both sides by negative 2. And we will cancel negative 2 and negative 2. And what will remain is cosine 2t is equal to negative 1. Now, to get that value of 2t, we should transpose cosine to the other side. And if you will transpose cosine to other side, what we will get is cosine raised to negative 1 times negative 1. Cosine raised to negative 1 times negative 1 is equal to 2t is equal to 180. And to get t, we should divide both sides by 2 so that the 2 in the other side will be eliminated. And cancel. T is equal to 180 over 2 is equal to 90 seconds. Now that we get the time at maximum, our final answer is, in minimum, E is equal to 2 joules at time is equal to 0 seconds. And in maximum, energy is equal to 50 joules at time is equal to 90 seconds. Hi guys, I hope that you enjoy my video tutorial for today. And if you do, please click the like button below. Thank you.